Thank you, students. Today we are going to see about big M method, minimization type. We are going to see here. Z equals to y1 plus 3y2, subject to y1 plus y2 is greater than or equal to 5, comma y1 plus 2y2 is greater than or equal to 6, y1 comma y2 is greater than or equal to 0. Okay. Step 1, changing minimization to maximization. We know already. So minimize z equals to minus of maximum of minus z. Maximum z star is equal to minus 2y1 minus 3y2. Okay. Now, step 2, to obtain the big M objective function. How we are doing that, we know already. Here maximum z star is equal to, see here, here greater than or equal to comes here. Where's that? Greater than or equal to comes here. We have to subtract one surplus variable, and here is another one greater than or equal to another surplus variable. Then artificial variable we have to add with them, plus a1, and then equal to we have to put here 5. So similarly, y1 plus 2y2, so we have to subtract s2 plus a2. Artificial variable we are adding, now equals 6. You go there, equals 6. Now where y1, y2, s1, s2 all are j1, a2 all are greater than or equal to 0. Now we have to add this. Okay, you will get 2y1 plus 3y2 minus s1 minus s2 plus a1 plus a2 is equal to 11. Then I told you that how to make the modified equation. Objective function plus minus m into a is equal to 0. The objective function you have to write as it is. Okay, look at that. This objective function we have to bring all this side, these variables bring this side, and that's what this minus m into, we are adding this we have to write it here, this we have to write it here. Okay, now the simplifications of this, you will get that here 2, here minus m 2y, therefore 2 minus 2m into y1 plus 13 minus 3m into y2 plus m into s1 and plus m into s2 plus m into s2. Then artificial variable, here ma1 minus ma1 get cancelled, here ma2 minus ma2 get cancelled there. And then we are getting this minus going that side, we are getting this. Okay, why is this coming in? I could not understand. Again coming there. Right, now this is what we get here, and then the second constraint we have to write as it is. See here, and y1 plus y2 minus s1 s2, y1 plus y2 minus s1 plus 0 s2 plus a1 plus here 0 a2 plus 0 z star is equal to 5. That's what this constraints, and this constraints is what y1 plus 2y2 plus 0 s1 plus s2 plus 0 a1 plus a2 plus 0 z star is equal to 6. Now step number 4 is simplex table. We are putting all these equations in this box. y1, y2, s1, s2, a1, a2, z star, c, b, and everything. Okay, now look at that. y1 and right here 2 minus 2m. Then the coefficient of y2 is 3 minus 3m. Coefficient of ms is m, and coefficient of ms is to 2, then take this equation, that coefficient is written here, that coefficient is written here. Now the basic variables are the canonical form equations. So a1 here, stay to that, a1 here, a2 is canonical form, just is canonical form, equation 1, 2, 3. Now test for optimality. What I told optimal, test for optimality means, I told you that this is maximization problem, but negative number is coming here. So that shows that optimum is not reached. Optimum is not reached because of the negative number. But which is the maximum negative number here is, of course, yes, look at this. Now this is so the incoming variable, this is a maximum negative number, therefore this is incoming variable y2. I already told to you, am I correct? So what we have to outgoing variable, to find outgoing variable, the minimum replacement ratio. Here 5 by 1, 6 by 1. 5 by 1, 6 by 2 is equal to 3. So minimum replacement ratio is 3. So outgoing variable is A2. This is pivotal element, we have to make it 1, and here we have to make it 0, here also we have to make it 0. That's what the next step comes here. Okay, so this is what we have to do there. Now this is the formula that we have to understand. Now look at that. You will see that 0, 0, 1 is coming there. Okay, so we have to make it here as that. Here you have to make it 0. So multiply this equation by -1, add with this. Add with this, actually, this equations. Okay, if you add this equation, you will get 0. So multiply this equation by -1, add with this number, this number, I will get this particular row you will get. Okay, this particular row you will get. Again, using this, we have to make it here 0. Here 0 we have to make. So multiply this, that is this equation, this number, -3 plus 3m, multiply this, -3 plus m, and add with this, it will be 0. Similarly, multiply this by -2 plus 3m, add with this, multiply this -3 plus 3m, and then add with this, you will get this term you will get. Similarly, multiply all this -3 plus 3m, add with that first row, you will get this, this. Okay, so now what you see, the basic variable a1 is equal to 2 and y2 is equal to 3. These are the basic variables we have because they are in canonical form. See there, a1 is canonical form, and similarly here this one y2 is in canonical form. We have written here. Okay, now optimality test here again. It is not reached. Optimum is not reached because the maximum here minus number comes. Optimum is not reached. Okay, so minimum replacement ratio 2 by 1 by 2, 3 by 1 by 2. 2 by 1 by 2, 3 by 1 by 2, the minimum is 4. That means this is the outgoing variable. J1 is outgoing variable there. So outgoing variable is A1, incoming variable is Y1, the intersecting element is this, and that's the pivotal element. Now our next table is this, you have to make it 1, and then you make it this 0, you make it this 0. To make this one, multiply by 2. So you do all these things, that is the next row. So that is outgoing variable row. So multiply by this 2, multiply this by 2, here 1 you will get, multiply this by 2, multiply by 2, multiply by 2, all these things, and that is what the this row you are getting, that is the row equation number 8 you will get. So equation number 8 will get there. Okay. Right. Now what? So this is what you have here 1. So as soon as you make this is equal to 0, you have to make it make it 1. You have to make it here 0, and you have to make it here 0. So what we have to do? So multiply this by 1 by 2 is here. Multiply this by 1 by 2, add with this. Multiply this by 1 by 2, add with this. Multiply this by 1 by 2, then add with this. Multiply this by 1 by 2, then add with this. Add with these elements. That is equation number 6. Multiply by 2, then add with that, you will get that particular number. So you will get 0 here. Okay, right. So similarly here we have to make it 0 here. So here 1 minus m by 2. So multiply this by plus 1, minus 1 plus m by 2. Multiply this, add with this, you will get 0. So that operation you do for the all the elements, you will get this particular row. Okay, that is multiply this by what number? Minus 1 plus m by 2. Add with this right here, you will get 0. Multiply this by minus 1 plus m by this number, and add with this element. Okay, you will get this. So like that you do all, you will get this particular equation. Okay, now test for optimality. Here the Z star is a maximization problem. Here these are positive numbers, therefore the optimum is reached. Optimum is reached. And with this as a basic variable, y1 is equal to 4, y2 is equal to 1. The variable which are not given here, you have to take as a non-basic variable. Here non-basic variables are S1, S2. So S1, S2 is equal to 0, and y1 is equal to 4, y is equal to 1. Substitute this value in the maximization problem given at the beginning. So maximum Z star is equal to minus 2 into y1 minus 3 y2. Here the value y1 is equal to 4 and y2 is equal to 4. Substitute that, you will get minus 11. But minimization problem is equal to minus of maximization of Z star. Okay. Therefore, we get as minus of minus 11 is equal to 11. Okay. This is the final answer for our problem. So this is the way we have to do the problems by Big M method. Big M method we can do by this method. So thank you very much for listening to me so much, and I will see you in the next class. Thank you.